When building a React app, at some point you'll have to render a list of items. It could be a list of products, users, or tasks. In this video, you'll learn how to render and manage lists within React. My name is Larry, and this is Digital Logic. I've got a new React project open, and the development server is up and running. Open up the app.js file and remove everything within the header tag. And then remove the import for the logo. Before we can really do anything, we need to have a list of items to render. So create a new state variable named items and set it equal to useState. And pass in an array of strings as the initial value. So I'll start off with walk the dog. And let's see, I'll need to feed the cat. And find something meaningful to do in life. And while I'm at it, I might as well solve world hunger. To display our list of items, inside of the header tag, add some curly brackets, and then pass in the items array. The array is getting rendered to the DOM, but is devoid of any formatting. What we need to do is transform the array of strings into an array of JSX elements. To do this, we can use the map function available in the array object. Pass in another function, which will transform each item in the array. The first parameter is the current item. Then return a JSX element. Save the file and check out the results. Now each item within the list is wrapped by a p tag, but you'll notice that we're getting an error message in the console, which states each child in a list should have a unique key property. But what does that mean, and what should we do about it? In essence, React needs a way to identify and associate the DOM elements with the data that is used to generate it. But why? What if I were to remove the second item in the array? From React's perspective, the text for the second and third items has been modified, and the fourth item has been removed. But if we had a unique key to identify each item, React would have realized that all we did was remove the second item, and it would have updated the DOM accordingly. A list item's ID should be generated by data. It needs to be stable, which means that it doesn't change over the lifespan of the running app, and it needs to be unique. We could use the item's index provided by the map function and assign that as the key to the list item. It will silence the error messages, but this key isn't stable since it can change anytime the array is modified. We could use the string value of each item as the key. It is better than using the index, but it's not guaranteed to be unique, since nothing can stop me from adding the same item twice to the list. A better solution would be to generate a unique key for each item and store it with that item. There are several different ways we can do this. I'll install an additional package to help out. So open up a terminal and type npm install UUID. UUID stands for Universally Unique Identifiers, and it allows us to generate unique IDs within a distributed environment. It's a little overkill for what we need, but it will work just fine. At the top of the file, type import, and within curly brackets, v4 as UUID from UUID. So we are pulling in the named import v4 from the UUID package and renaming it to UUID. Now modify the array of items and convert it into an array of objects, where each object has an item property, which is the task, and an ID property, which will be the UUID value. Once that's done, modify the mapping function, destructure the object, and retrieve the ID and item keys. and I'll remove the index since it's no longer needed. Update the key property within the p tag to use the ID, save the file, and check out the results. Click on the app component and then expand the state variable, and then you can see that each item now has a unique ID assigned to it. Now what if we want to remove an item from the list? Add a new constant, handle remove, and set it equal to a new function. Add a button to the list item, and set its onClick event listener to the handle remove function. One challenge that we need to overcome is that when the handle remove function is executed, we need to know which element to remove from the list. One option is to pass the ID to the handle remove function, and then modify the handle remove function so that it returns a new function once it receives the ID. This new function forms a closure over the ID parameter. It also means that each list item will receive its own unique copy of the handle remove function. One limitation of the solution is that we cannot use the use callback hook with this event listener. Now we just need to remove the item from the list, add a call to set items, and pass in a function with a single parameter items. Before we update the array, remember that state within React should be treated as a mutable object. That means that we can't just remove an item from the array. That would break the immutability part of state. What we need to do is duplicate the array without the item that we want to be removed. An easy way to do this is to use the filter function, which will return a new array of every element that passes the filter criteria. Pass in a function where we'll take each item and check if its ID is not equal to the ID passed to the handle remove function. Save the file and check out the results. And now when I click on the button element, the item is removed. Another option to retrieve a list element within an event handler would be to tag an HTML element and then retrieve that tag within the event object. So comment out the handle remove function and define a new one. We will need access to the event object, so make sure to add a parameter to the event handler. Update the event listener so that we're passing in a reference to the event handler. And then add an ID attribute to the button element and set its value to the list item's ID. Within the handle remove function, add a call to set items and pass in a new function with a single parameter items. Call filter on the items array and pass in a new function where we take each item and check if its ID is not equal to the event.target.id. Save the file and check out the results. And you'll notice that it's working as expected. But there are a couple problems with the solution that we do need to deal with. Most likely, you'll need more than one event listener on a single item. In our case, we could add an edit button. We'd also have to add an ID attribute to the button element so that we can identify the item in the list. But the problem is, the ID attribute on an element should be unique to the HTML page, and we now have two elements with the same ID. This won't break anything. Our app will still work just fine, but a better option is to store data on custom attributes. So update the ID property on the button to data-id. And then update the event handler so that the property that we target is e.target.dataset.id. Save the file and verify that it still works as expected. And then if you look at the HTML for one of the list items, you'll see that the custom attribute is assigned to one of the button elements. The other problem that we need to deal with is event propagation. When an HTML element receives an event, like a click event, that element's onClick event listener will be executed if one is defined. Afterwards, the element's parent's onClick event listener will be executed if one is defined. This process continues all the way up to the document object. This is called event bubbling. Event capturing is the exact same thing, only it travels in the opposite direction, starting at the document object and traveling down to the element that received the click event. So why does this matter? For our current example, it doesn't. But if our button component was more complex, if it had an icon or an image element inside it, it would make a difference. To help illustrate this, let's wrap the button's text with a span element. Save the file and check out the results. If I click directly on the X, the item is not removed. In this case, the span element is the target of the event. But if I click off the X, still within the button, the item is removed. The default propagation mode is bubbling, so when I click on the X, the event is executed on the span element first, and then propagates to the button element. That's when the handleRemove function is executed. The problem is that the target property references the span element, which does not have a data ID attribute, so nothing is removed from the list. Instead of using the target property, which references the element that the event originated from, we can use the current target property, which references the element that the event listener is registered on, which in this case is the button element. But there is a catch. We can't access the current target property within the setItems function, because the current target property will change as the event propagates down the component tree. When the event is executed on the button element, the current target property will reference the button element, but when the event propagates to the button's parent element, the current target property will be set to null, because that element doesn't have an on-click event listener. This is only a problem because the function being passed to setItems will generate the updated array asynchronously, at which point current target will be null. There are two different ways that we can solve this. We can save a reference to the current target property, or we can generate the updated array synchronously and then pass it into setItems. I'll save a reference to the current target property, and then use that reference in the filter function. Save the file and check out the results. Now it doesn't matter if I click on the span element or the button element, the item will be removed. Before moving on, let's encapsulate the list item into its own component. Create a new directory, Components, and then a new component, List Items. Cut the p tag from the app, and then create the components function. We'll need an ID property, the onRemove event listener, and then the children property. Return a JSX element, which will be the code that we cut from the app. Change the items property to the children property, and then update the onClick event listener to use the onRemove event listener. Back in the app, add the list item, and then don't forget to export the list item so we can import it into the app. Set the ID property, the onRemove event listener, and then set the item property as the child of the list item. And then finally, make sure that your IDE imports the list item. And I forgot to add the key property. Save the file and refresh the browser. So you can see each list item has its own unique key, and we can remove an item by clicking on the X. Next, we'll add the ability to add new items to the list. Create a form element, an input element, and a button element with the type set to submit and the text to add. Create a new state variable to store the value of the input element, and set the default value to an empty string. Create an event handler for the input element. I'll name it handle input, and this time I'll use the use callback hook. And I'll define an empty array for the dependency array. Within the event call set input, and set the value to e.target.value. Create the handle submit function. And of course, define a dependency array. To prevent the form from submitting the data through a GET request, call e.preventDefault. Add the new item to the list by calling setItems, and then pass in a new function. Just like before, we can't mutate the existing state array. We need to return a new array with all of the items in the current item list plus the new item. So from this function, return a new array, use the spread operator to expand all of the enumerable properties from the existing list, and then add the new item to the end of the array. And because we're relying on lexical scoping to retrieve the current value of the input element, add it to the dependency array. And finally, clear out the value of the input element. Add the event handlers to the form components. Save the file and check out the results. And of course, try to add a new item to the list. And it works. Right now, we are storing the list of items in an array. The only downside to this is that anytime we want to access a specific item, we have to iterate through each item in the array. This isn't a huge deal. I mean, after all, every time the component renders, React iterates through each item in the list to produce the final JSX. But if we can avoid one extra iteration, I say why not? To do this, we're going to convert the array into an object where each item is keyed by its ID. This will allow constant time access to any one element within the list, as long as we know the item's ID. First, cut the list of items from the useState function. Outside the app function, create a new constant, data, and set it equal to the initial array of items. Pass in a function to useState, and then call data.reduce. The reduce function will allow us to take an array and reduce it to a single value, in this case an object. The first parameter to reduce is a function, and for this function I'll define two parameters. The accumulator is the accumulated value, and the current value is the next item in the array. And then define a new key on the accumulated object. That key will be the current object's ID. And I'll set this equal to the current object. Make sure to return the accumulator, and then we need to define the initial value of the accumulator, which is the second option to the reduce function. And I want the initial value to be an empty object. Update the component's JSX. We can't call map on an object. We have to convert it to an array, so use the object.values function, which will return an array of the object's enumerable values, which we can then call map on. Now in this case, we don't need access to the key, since the ID is also stored with the item. But if you need to access the key, you can use the object.entries method, which will return an array of key value pairs. Then I'll update the list items key property to use the key parameter, which has the same value as the ID. Update the handle remove function, comment out the call to set items, and then call set items, pass in a function, and then use destructuring to create a copy of our object. This will copy all enumerable properties from the current items array into the copy, and then use the delete operator to delete the key with the current ID. And then return the copy. And make sure to use the current target to get the item's ID and not the event, like I just did. So in this example, we create a copy of the state object and then delete the key value pair that we don't want. But we could also use destructuring to extract the key value pair that we don't want into a separate object. So comment out the current solution, create a new constant, and within square brackets, add current target.dataset.id. This is a dynamic value, so we need to define a variable to store it in. So add a colon and name it temp. Then use the rest operator to collect all other enumerable properties from the item's object. Finally, return the rest variable. Save the project and verify that it works. Now we just need to update the handle submit event handler. Comment out the old set items code. Call set items, pass in a function, and this time I'm just going to return a new object. Spread out the properties in the items object, and then create a new variable to store the item's ID. And then create the new object. Save the file and verify that it works. Notice that whenever I add text into the input field, all of the list items get re-rendered. Anytime a parent component is scheduled to be re-rendered, all of its children, the list items in this case, also get re-rendered. To reduce this, isolate the form into its own component with its own internal state for the input element. You can also add the useCallback hook to the handle remove function. I just never got around to it, but it won't prevent the list items from getting re-rendered. That's it for this video. In the next video, I'll be going over how to build reusable and configurable components in React. If you like this video, then please like, share, subscribe. If you want to support the creation of these videos, then check out my Patreon page. The link is in the description, and I'll see you in the next video.